Okay, so we are gonna do mostly in CI today for our lab, so that way you can see how that is in practice. We are gonna go ahead and download the virtual machine from Kali. That's the easiest way that you can use Linux without creating it. So there are times that we're gonna use Kali quite a bit in this class as we proceed, but there are times that we're gonna use Windows system, so just our desktop. So go ahead and click this link and it's gonna take you to Kali. Let me re-click the link. And you're gonna click this little arrow to download, as I screenshot that for you already. It's gonna take a few minutes to download. And if you click save, so when you click that, I know some of you are using other browsers, so make sure that you save it to a place where you can find it. What happens is if you try to just open the file that it's temporary download, it throws it into a temporary folder. So you can just download it to the computer and save it on the desktop or on the downloads folder. So for me, as I'm using Chrome, when I click this, it's gonna download it and it's gonna place it into the downloads folder by default. So after we download, you're gonna see a zip folder like this in your downloads folder or wherever you saved it. And all we have to do is we can right click it, show more options, 7-zip, and extract files. Now, if you try to extract it with their regular Windows tool, it's still gonna work, but it might act a little funky. So again, once you download the virtual machine from the website, you have a zip folder, right click it, go ahead and choose show more option. And 7-zip is the software we're gonna use to extract and then extract files. And then this is gonna pop up. It's gonna store it in the same location where you have the zip file. You're gonna click OK. And it's gonna take a few minutes. So we want to extract this. Now, after this, you don't have to save it, right? If you copy it to your, remember, when you have an extracted file, a folder like this, right? Remember what it says here, it's 3 gig. Even though it's smaller than your USB drive, it's not going to transfer well. So if you want to save the zip file, you can copy it into your drive, or you can just always download it from their website. And they have different type of Kali virtual machines there, okay? So I want to extract it using 7-zip because that's what the school has. At home, if you're using this, 2 things that you need. You just need to have the VirtualBox application. It's like a player. So you can install that and you can download it from Oracle VirtualBox. And you just need to re-download the VirtualBox itself and then extract it. If you're using Windows PC, it comes with an extraction or decompression tool out of the box with the OS. If you're using Mac OS or Linux, they all come with the decompression tool, right? So they do have documentation for you to follow. So which step am I at? I already downloaded my Kali. I already went to my downloads folder. By default, it's saved there. So make sure you save, because I noticed that on Monday when I was teaching my 27 class, they just click download and then they try to open it as a download and it's compressed. So they are not able to play their virtual machine that way. So just save it first to the computer and then extract it and then you can play it. Okay. So I saved it to my downloads and then I went there and I extracted it. So I right click, show more options, 7-zip, and extract files. And then once that's done, which is step 4, I'm going to go ahead and look at you know, for step 5, it says that you can do, so there are 2 ways to play. If you already have VirtualBox installed, you just simply open up the folder and its subfolder, and you're gonna find the blue icon file and you can double click it. And then it's gonna play. Or you can go to VirtualBox and then you can add and then browse to the decompressed folder and then click start. Okay. So if you just open up the folder itself and double click the blue icon, it's gonna play. And it's gonna boot the Kali if you're not touching any kind of key after a few seconds. And I think it should be like 6 or 7 seconds.
How long is it supposed to take to download?
Only a few minutes
Okay.
on my end. Maybe sometime it's a little
Like 1
longer.
minute. And it's a tough one, but.
Yeah, it's the top one.
Oh, that's good.
All right. So once we have Kali up, it should be pretty easy. So while that's booting up, I'm gonna go ahead and take a look at the next step. So once my VirtualBox is open up and ran, I'm gonna go ahead and log into Kali. So here, the username I put right there for you on the document, and you can find this on their website. You're gonna go ahead and type Kali lowercase and Kali lowercase and click login. So this is the desktop for your virtual machine. We are mostly gonna use the terminal, which is the command line for Kali Linux. Now, do you have to use Kali to do this? No, right? The steps that I wrote would work with Debian Linux. So if you're using Ubuntu or even your Raspberry Pi, as long as you install the tool and if your Linux machine has enough space or resource to install, you're good. In the future, when we're using Kali, sometimes we're using an encrypt tool that's built into Kali. So that way you don't have to install, then that's different, okay? So for today, what we're gonna be doing is we're gonna start with encryption, right? I did this with the high school and they are successful in an hour and a half. So I believe that you can all do this very swiftly. Yeah, so it's not done downloading.
Oh,
So, yeah, so whenever you download, so I would recommend saving the download. It should prompt you to save because I think you're trying to open it as a download. Why don't you re-download it again? Click download and then save.
Save that.
And then, yeah, you can save it into downloads. All right, and then when it's done, it's extracted. Any other questions?
Were you able to decrypt it?
With the command.
Cat copy my secret text? Oh, that,
Cat is just to read.
well, cause it came up as a, I have to decrypt it. It's encrypted. Yeah, I think I know what you're talking about. Which step? Where does it right? 30, yeah, I did that, but when
Okay,
okay, so.
so the first part we're gonna do is we're gonna use encryption. And this is part of confidentiality. So we are gonna use ccrypt. Okay, and ccrypt work for Linux, which is originated in Unix. So earlier I mentioned that you need to pay attention to the algorithm that you're using. So ccrypt, it is a original cipher, and it is a good candidate when you are looking at AES. So here is the link for that. So when you're using Cypher, all you're doing is you're making things not readable, right? So what we're gonna do first is we are gonna create the file so that way we can encrypt. So back in your Kali, you're gonna open up your terminal by clicking the black square box. So we're gonna click here, and then we are going to make a folder, right? Inside the account folder called Kali, we're gonna do an mkdir to make a directory called secret. So in the first, on step 10, you are going to open up your terminal by clicking the black square box, and you are going to make a folder by using make dir command and the name of the folder, which is secret. So once you type that in, you're going to press enter, and it's going to create that folder. Once we have the folder, we are going to go inside that folder, just like open up that folder by doing a change directory command. So we are going to do, so now we have the folder, we're going to open it up by using cd secret. So we're going to change into the directory, and notice that your path has changed here. We learned this before from other classes. And what we're going to do is we are going to use a cat command to create a text file called mysecret.txt. So cat stands for concatenation. And what we can do is we can use it to read a file. And if the file doesn't exist, we can use it to create a file and put in the text. So we are going to go ahead and use the command cat and use the arrow key mysecret.txt. When you press enter here, it's going to go into a text editing mode, right? Notice that it doesn't pop up your user account path anymore. So what you're going to do is you are going to type in the text for your file. This is my secret file. And once you're done typing in the text to put into that text file, you're going to press Control and the D, as in David, key together. Oh, helps you. If I do that, you got to click inside the virtual machine if it's not responding. So what I just did there was I completed step 14 and 15 after I used the cat command to create my file and put in the text for my file using the text editor that it allows me to do that. And then I press Control D and to go back into my terminal pop-up. So I wanted to check to see if that file exists by doing an ls or an LSL. So when you're using an LSL, all that is it's going to give you the property of the content of that folder. So that means that I have the file here, its permission, and its information, which is its property. So we know that we created the file, right? And if you want to read it, you just do a cat secret.txt or mysecret.txt and it should pop up the content. So at this point, we're going to do a screenshot. We can do a snip. And I can create a new snip by clicking this, drag it, put it on my lab. You can use this direct document. You don't have to make it that big if you don't want. The reason why is you would save this later and submit it, but you should save a copy so you always can see, go back and look at the lab, what it looks like down the line, in case you need a reference. Okay. So after we have the screenshot of our file that we created, I just want to make sure you created the file. We are going to do an update for our Linux. That might take a few minutes. So we're going to do a super user do apt get update. before you install any software, it's always good to do an update. If it asks for the password is on the first part. So Cali, lowercase, the cursor doesn't change, just type and press enter. Okay? If you wait for the cursor to change, then it's not gonna change. Just type and press enter.
April? Alvaro?
Any questions? Okay, so depending on how old your version of Kali, since it's fairly new, we just downloaded it. The updates doesn't take very long. So we got the packages that we need. Now we're gonna install our software. So you are going to go down and you are gonna install the ccrypt, and you are gonna use sudo apt-get install ccrypt. So I am now at step 19. And if it throws an error, it's because you have a typo. Okay. So now I have my software installed. That means that I can encrypt or decrypt. So ccrypt has been around for a long time, as I give you the explanation. And so the command that you would use with it is going to be cc encrypt and then the file name. After that, it's going to prompt you to create a security key. Okay. So let me minimize this a little bit. And so I can have it together like this for you. Okay. So what we're going to do next is we are going to encrypt our file. Since we're already in that folder, make sure you're in the right location, right? We CD into that earlier. We changed the directory. So we're going to go ahead and do. I'm having a hard time capturing my mouse and keyboard here. Oh, so frustrating. It's just not displaying everything. All right, so we're just gonna go ahead and do that. And you guys know that you can copy and paste. I don't encourage you to do that because I wanted you to remember what you type. But Kali lets you do that. And we're gonna do my secret.txt, right? So our file name and then the encrypted file. So now it's going to give you a security key. And by this, we want to make sure that we practice security where we would use lengthier security key, right? But I have you just use this because it's quick. So we can say secure 01 with the capital S. And just type, right? Don't pay attention to the cursor. And then you would repeat that. Okay, don't worry about the blinking cursor, just type, okay? So once we created the key and validated the key, making sure that we have the right key, you're already in secret, so I don't think you need to do step 23. And then what we want to do is we want to check the status of our file if it has changed. So we're going to do an ls-l. And you notice that when it encrypted, it added another extension called CPT. So when it encrypted, it added another extension to your file. So at this point, we're going to screenshot. Okay. So I'm here, 24 and 25. We're going to take a screenshot showing that I have encrypted my text file. Now, depending on your encryption tool, ccrypt would put the CPT after your file extension. Okay? Any question? Yes. Yeah, so it's not extracted. You can extract it. Okay, so as we saw that we have the encrypted file, next thing that we're gonna do is we are going to take a look at the file extension. What file extension does it have? So we already answered that, right? .cpt. And how is that comparing to the old file that you created, right? Because it's encrypted, so the file has an additional extension for the encryption. Then we are going to create a copy of it. So I wanted you to see that when you copy, it doesn't necessarily, so how is that going to be for its property? Okay. So we're going to do, I'm going to copy and paste this because I want to make it fast. We're going to copy the encrypted file, and then we are going to make it name copy my secret.txt. Okay. So we're going to copy the encrypted file that we created, and we are going to name it copy my secret.txt. And once that's successful, nothing happens here, but it did place the copy of it as this name. And then we want to read it to see if we can see its content. Remember that the original file that was copied was encrypted, right? So let's see if we can see the content. So as we copy it, the nature of the file or its property is gonna also get carried. So you see mumbo jumbo, right? Symbol, because it's not readable. So we can see that it's also encrypted. Take a screenshot here. Describe what you see. Is the content in plain text? No, right? How do you determine if the file is encrypted? It's because we can't see plain text. We know it's plain text because we put it there earlier. So the whole point of this is to make sure that you understand how encryption works. Even if you copy an encrypted file, right? It's going to inherit the characteristic of the original file. Until you decrypt the actual file, right? Because you encrypt the original file, you have to decrypt the original file to copy so you can see the content. So now what we're going to do is we are going to decrypt the original file. Okay. So we're going to do a cc decrypt my secret .txt. Actually .txt.cpt, right? And then you need to put in the key that you created, which is secure01. And we just type, don't look at the cursor. And after that, we wanted to see its state if it's changed back to just a .txt file because it was a .cpt. So we want to do an LSL to see if it changed back. And it did. So we successfully decrypted. So at this point, after you decrypt and list the content of the folder to see that it goes back to the original state after the decryption, take a screenshot How do you know it's decrypted? One thing that you can see is that the CPT file extension is gone, right? It's going back to the .text. You can also read it. So if I do a cat my secret.txt, I should see the text, the plain text that's in the file. Okay? Because earlier you saw that when we copy it, when it's encrypted, it's just symbol. Now, when we decrypt it, I put secret file. I typed it wrong. But it should be my secret file. So if you read it by using cat, you should be able to see its content. So after you put that, you take a screenshot here. Now we're gonna go ahead and go back and we're gonna access using cat. We're gonna try to read the copy file again to see if it's different. Because remember, we encrypt the original file, we copied it, right? Now we decrypt the original file. Maybe it will change when we decrypt. What do you think? It's different file, so we didn't decrypt the second file, so we're gonna do a cat copy my secret.txt, and it stays the symbol because the one that got decrypted was the my secret, not the copy of it, right? So does that make sense? Even if you copy the encrypted file from the original, it stays encrypted. You copy the encrypted, so it stays encrypted. When you decrypt the original, it stays encrypted because it's a separate object. It's not the same object, right? It doesn't share any kind of property. There are two different files. So how can I decrypt this? What do you think? It's not really encrypted, isn't that true? It's just a copy content. We copy the content of the encrypted file. So technically you can't really decrypt it. Okay? All right, so compare the content of my secret.txt to the copy file. Are they different or the same? Of course they're different. The copy file stays encrypted, or it stores the encrypted content, right? Which was copied when the original file was encrypted. How do you determine if my secret.txt is decrypted? Because it has plain text, you can see it. And the extension, the file extension is gone. So it's the same answer as 36. And so now we can do the same thing with the private.txt. So we're gonna go ahead and do a cat with an arrow, private.txt. And we can say this is my private file. And I'm doing the next step now. I'm doing 43 and 44. Right? So once I put in the content of the private.txt, I'm going to press Control D. And then I repeat the process, right? So I'm going to do a cc encrypt private.txt. And then I make a key, so we can say secure 02. I think I typed that wrong. Let's repeat that. Okay. So once we created a key for the encryption of the private dot text, I'm gonna do an LSL. So now I see that it is encrypted, right? And I can try to read it. So cat private dot txt dot cpt. Nothing, mumbo jumbo, right? Can I just read the dot text file? You think it's gonna throw an error? Of course it's gonna throw an error because the state of the file has changed. The extension is added, so it no longer know that there is a private dot text. It doesn't exist. Okay. So I encrypted the private dot text. And I can take a screenshot of that. That's all you need. Now I'm gonna do a ccguess with a private dot text CPT. So the file that we just encrypted. So let's say that I'm trying to see the content of this file, but I'm not sure of the key, right? So ccguess, I put down here that you can use this command to recover your key. In the case that you kind of remember what it is, but you're not sure, right? Because, you know, all of us have many, many different passwords, okay? And sometimes we don't always remember, and it might be a while. So what we can do is we can kind of put in some of the characters that we remember, right? And see if it guesses it. So I'm just going to try SE. So if you read into this, it actually does the enumeration process based on the software, how it's built. But when you take a look, so it has a library of patterns that it would use. And as any developer would do, it's going to try to use some kind of container, and it's going to try to throw in various characters. It's tried and true, basically. And then see how you notice that it's going through, and it's going to enumerate through different digits and values. Okay. This is easily done in programming, right? With ASCII. And then, so when you use tools like this, you kind of have to think about how it's designed. And, you know, so that way, in the case that you need to troubleshoot it, you can kind of figure it out. So this might take a little bit. It really depends how long is your key. So I wanted to show you that if your key is longer, it's going to take a lot longer to guess it, right? But if your key is really short, like if I have only 3 characters or 4 characters, it will take a lot quicker time to really guess it. So for someone who's trying to access your document, like an unauthorized user, right? They could use something like this to access it if you encrypt it, right? Trying to guess your key. But encryption is not about trying to brute force the key, isn't it? So if I am the attacker and I'm trying to access your encrypted document, I'm not going to sit there and enumerate through all of these characters forever. Your key could have been, you know, 100 characters long for all that matters. If you guys ever use, you know, drive encryption, like from Windows, it generates a really long key. But the downfall in that, it asks you where you want to save the key. You want to put it on another USB? You want to print it out? Right? It does prompt you that. But anyway, so how do I get to access your document if it's encrypted? I don't try to guess your key. I will try to take your key. Right? That's a smarter move. Okay. So this might go on a little bit, right? This is probably gonna be like the longest time. After a while, if you don't see any kind of response, you can put down the number of tries because it tracks it. It tells you how many tries, and you can always press Control-C to cancel in Linux. At some lab, we're gonna have to do that because it's gonna go on for days. Okay. Did it match?
No. This is what I got.
So that would give you the answer to if you ever want to use ccguess, right? Not a good tool.
Yes, but, hey, it's stopped. I didn't have to push the full C.
Yeah. But also the environment that you're using it in is a virtual machine with really limited resources. So it's really slow and you know, not accurate.
It's the past, your final assignment for CIS41A. I did attempt to brute force one of the passwords.
Oh, really?
It crashed, so I had to give up.
Oh, yeah. So for CIS27A is the forensic class that Brandon had with me. I think some of you are in that same class. You're in here. And they were to discover all of these documents and pictures and things from the case. And they also find passwords, right? Yeah, you can try to brute force. There are tools for you to use to find plain text password information. It just depends on how much resource and effort you want to put into that, right?
To say I did not find the
Oh, yeah. So yeah, like the embedded file. Mm.
yeah, like I knew it was encrypted. Where is it?
So here it tells me that, right? And then sometimes it doesn't, mine just kind of stalls. So let's do Control-C. If you press Control-C, it can. So you can just screenshot that. It doesn't give you the matches or the matching key. So if it doesn't give you the try, you can just say unknown. Like for mine, it didn't. But if you have some kind of tries, it normally tells you how many tries that it tracked. And then is there a match? Right? I didn't have an actual match. Then we're gonna use the ccat on the next one. And these cc commands come with the C and the ccrypt. And that was private.txt.cpt. So another way that you can access the file is to use ccat and ccat. And ccat is basically, it's the way that we can read the file. And in order to read an encrypted file, you have to decrypt it. Okay. So does that make sense? So in this particular command, it entails the decryption if it is encrypted. Okay. So here it tells you it's used to display the content. For the syntax, it needs read access. So if the file is encrypted, the file must be decrypted. Take a screenshot. And then now what we're gonna do is we're gonna check to make sure that if it's still encrypted by doing LSL. And so notice that it didn't fully decrypt because we didn't issue the decrypt here. It just reads the content of the encrypted. So someone can use ccat to read an encrypted file, right? because my private.txt is still encrypted. But ccat is able to see its plain text. So that's the downfall for ccrypt. Even though it is implementing one of the stronger algorithm, but the commands for the tool is able to let you see the plain text of an encrypted file. Any questions? Yeah, it didn't. It didn't. For me. I pressed Control-C to stop it. And then on the last part, we're gonna work on integrity. And on this one, we're just gonna work with hash. So we want to make sure that there's no unauthorized modification to our file or our system. And hash is an algorithm that we can use to assign to a string or a value to a certain file. So what we'll do is within the same folder that we have, the secret folder, we're going to make a test file. Getting dry. So you can do it two ways. You can do a touch and make an empty file, or you can just do a cat like before. And then we can do a test.txt. And then with that, we can say this is a test file. And then Control-D. If you do a touch, it just makes an empty file. You can also nano the file and then use editor to add it. So what I did with that step, and I am at step 55, I just use the cat command with the arrow and then the file name. It brings me to the text editor. I put in, this is a test file. Press Control-D. We've done that before in the earlier steps, and it's going to bring me back to the pop-up. Then what we're going to do is we are going to use SHA-256 hash for the file. So you simply, and you know, Kali comes equipped with this, most Linux does. So you can do SHA-256 sum and then the test file. What that's going to do is going to generate the hash for that file. But remember that when the file is created, it's already have a hash. What we're simply doing is we're using an algorithm to generate that type of algorithm hash. Okay? So there are different type of hash generator that you can use. So preferably we would use something that's stronger than MD5. If you have read and learned about MD5, it's very, very weak. So we are gonna do, I'm just gonna copy and paste this because it's quicker. So when you do this, when you do a SHA-256 sum and the file name, that's the file that we created, it's gonna generate this hash string for the file. It lists that there. So what are you learning by doing this is to use, right, this tool to generate your hash value. Take a screenshot. What we're gonna do is we are gonna copy that hash value and we're gonna use the hash identifier to check it, right? So it's the hash identifier is going to tell you what kind of hash it is. So let's say that you're given this hash and you need to find out what kind of hash it is. You use hash identifier. So I'm going to go ahead and Control-C or right click and copy. And then I'm going to call on hash identifier. I typed it wrong. There we go. So once you have the hash identifier up, right, it asks you what kind of hash it is. And if you have copy from here, let me redo that. Right, okay. Copy selection. You can just paste it and then press enter. So it tells me that it is a SHA-256, and that's the type of hash that I'm working with. So once we identify the type of hash, take a screenshot. And when you are leaving hash identifier, you just need to press Ctrl-Alt-T to come back to the terminal. That's how you can get back to the terminal. It's just open up another terminal. Or I think you can do Control-C here. Control-C to use the same one. But in Linux, you can have as many terminals as you need, right? It just take up resources as it is in software application. And then what we're going to do is we're going to read the test file using, we're going to edit the test file by doing a cat command. Oops. So we're going to do a cat test.txt. And we're going to say this is modified. Then Control-D. Then we're going to regenerate the hash. And the point in this is we want to match up this after it's modified to this. You notice that it looks different because my original hash start with an F and my new hash start with a B. So when you generate it again, if it's modified, it's going to be different. Okay? So we see here that even the beginning values have changed, even when we're using the same tool. So take a screenshot of your hash value, the new one. I'm almost done and then we'll do attendance. I'll let you guys go. Then after that, what we're going to do is we're going to do the last part, which is hashdeep. So hashdeep is used to compare hash sums. And it also allows you, so if it display the match list or not, if things are not matched, and you can read Kali documentation on it. I think they keep it pretty brief, but you can also go find information on hashdeep. And hashdeep comes with Kali, so you don't, if you're using other Linux, you're gonna have to install. So we're gonna go ahead and use hashdeep. Test.txt. So what we see here is we see that this particular file have generated hash or have hash values. And it tells you those and then the location. So it tells you how many hashes. And pay attention to the separator. So I have one. This is the most recent one, right? The first one, and then there's also another value. So when the file was created, it has a shorter string for the OS itself to track. And then you have the value here. You notice that the F, the generated, this one is no longer there because it has been modified. So it's going to take over the new one is gonna store it in its place. So you no longer have the original, as is noted. Right? Where did this come from? This is from when you create the file. So now what we're gonna do is we answer the question and then we're gonna use the same command again to generate the hash. Because remember, we didn't really modify it, right? We simply just compare the hashes. So you come back here, if you up arrow key a few times, you are gonna, a couple of times, you're gonna go back to the previous command. And of course, it's exactly the same. And that's how you can tell that the file is not modified. I know that a lot of the books and things and the theory that you've learned, and we talked about hashes and things like that. I just want to make sure that at this level of education, you know how to use hashes the proper way. Okay?
They're saying like the Kali import is like too long or not valid.
What?
So right here. Like copy it like that.
Are you copying it where?
Oh.
Are you done? Sorry? Oh, yeah, you don't need to save it.
Oh, okay.
Yeah, we're just gonna use it for today. Every time we use it, we're just gonna download and extract. If you want, you can copy the zip folder to your USB drive so you don't have to download it in the future. But for the sake of, you know, this particular class, I guess I don't think that we have consecutive lab where we're gonna have to build on the previous lab. I try not to do it that way because that just sets up student for failure. Mostly the exercise is gonna be for that session, and then we will move on to the next tools the next time. I don't like consecutive labs like that, only like if I need to teach like Windows Server or, you know. For advanced security class, you are gonna have consecutive labs because we are gonna attack existing servers. Oh, let me stop the recording after I finish this part right here, and then I'll talk to you guys about the upcoming classes. So when you're done, you answer the questions and then you can shut down the system. So we're gonna do a shutdown now. And when you issue the now, it just gives it a 0-second parameter. And it's gonna shut down your virtual machine and you're done, right? Like I told Devin, you don't need to copy that virtual machine to another location. I know that you want to back it up, but you already know how to do this. So when you go home, if you wanted to practice, make sure you have VirtualBox to play the machine, download the machine, extract the machine, you can go through it. So by second or third run, you should be able to already know the steps, right? It's pretty simple. Okay. So what did we achieve today? We have used hash tools. We've used encryption tool, ccrypt. So make a habit of taking down the notes of the tools that you use, coming back and relearn it. And then that way you can add it to your resume. Okay, because by the end of this class, you're going to go through a lot of different tools. And then you're going to forget what you've learned the first day or the third week or down the line. Okay, so let me stop recording. We can do attendance.